Okay, so as I said, we're doing another example of basically the same type of problem, finding the basis for the null space and the basis for the column space. Again, it's going to be the same procedure as last time. So we start out by taking this and turning it into an augmented matrix, throwing in the 0 column at the end. And one thing you may notice is putting that 0 column at the end doesn't actually do anything. If it's 0, the whole column at the beginning, and you do reduced row echelon form, it's still going to be 0 at the end. So if you didn't really want to bother typing them in, you could save a little bit of time there. This time we're going to get the following for our reduced row echelon form. At least that's what I got in my calculator here. So we look at this, we do the same thing we did before. We first look for pivots. We've got 2 pivots here. This time we only have one free variable. All right, that's my free variable here. So again, if we have x, y, z, z is our free variable. And so that means we're going to rewrite our pivot variables in terms of free variables. So then I'd have x minus z equal to 0, x equal to z, and then I would have y plus 2z equals 0, so y is negative 2z, and then we go ahead and write down our arbitrary answer x, y, z as z negative 2z, z, or z times 1 negative 2, 1. And so that means the basis for the null space this time is only going to have a single vector in it. That's the vector 1 negative 2, 1. And furthermore, if I want to find the basis for the column space, we look at our pivots here, which were in column 1 and column 2. Go back to the original matrix, column 1 and column 2. And so then my basis here would be a 1, 4, 7, 2, 5, 8. So again, it's just a very, very standard process here. Just follow the steps, it'll work. There is one thing that can happen that's maybe a little strange at first, and I can do an example of that really quickly here. So this time I'm going to call my matrix B here. It's just going to be an ever so slight change from the one we just did. Instead of 7, 8, 9 in the end, it's going to be 7, 8, 10. We've seen this example before. I like to use it as an alternative. And again, just doing the same normal steps we've been doing. We go ahead and put the column of zeros. We do our reduced row echelon form here. And something different is going to happen in this case. There are 3 pivots, and there were originally 3 variables. And what that means is there is no free variable. And if there is no free variable, that means there's going to be no vector in the basis for the null space. So what you can do is you can say the basis for the null space is the empty set. It's the nothing. There is nothing in the basis there. This is a little weird for some people, and I understand that. Now what this means, if there's no free variables, then if you remember from our class how many solutions there are, there's going to be exactly one solution. And so the exactly one solution is going to be just the 0 vector. And so the null space, the set of all solutions, is going to be just the 0 vector, and that's it. And you are fine if you want to tell me that the null space is the 0 vector. You are fine if you want to tell me the basis is empty, but don't ever say that the basis is the vector 0. Mathematically, this does not make sense. You may recall earlier that a basis has to be linearly independent, and if you have the 0 vector, it's never going to be linearly independent. So I don't want to see that on your paper. I'm fine with you saying that the null space is 0 or the base is the empty set. I just want you to be a little bit careful on that you don't get the wrong answer there. And then lastly, we had 3 pivot columns. So we're going to have 3 vectors going into our basis for the column space. And so that's going to be 1, 4, 7. Remember, we use the original vectors here. 2, 5, 8, and 3, 6, 10. Okay, so at this point in time, I want you to be able to find the basis for the null space and for the column space. And that's really what we're trying to get out of section 2.8.